All right, students, let me try another video solution. This one from chapter 13, number 15. Let me read it here. It says 6 grams of liquid X are at 35 degrees. Okay, so 6 grams. Maybe I'll do this. I'll make a little figure kind of representing the liquid X. So here's liquid X. And then I'm going to even divide it into 6 pieces so that each little block here is a gram, all right? So this is my 6 grams of liquid X. So 6 grams of liquid X is at 35 degrees Celsius. It is then added to 3 grams of liquid Y. Okay, so liquid Y, we'll put next to it. We're going to mix this together, put a little Y, and I'll chop it into 3 pieces, 1 gram each. Okay, so 3 grams of liquid Y is then at 20 degrees Celsius. Now, it says here the specific heat of liquid X is 2 calories per gram for each degree Celsius. And the specific heat of liquid Y is 1. Okay, now that's going to be important, and I think it gets down to the conceptual nature that you can see when you mix these two, liquid X is going to cool down, and this one's going to warm up. But you can kind of see then that this one, to cool down 1 degree, has to lose 2 calories. Because it says its specific heat is 2 calories per gram for each degree. So if this were to drop down to 34 degrees, then each of these would lose 2, and of course giving it to Y, which would then go up by some matter. And that's where this question is going. It says, if each gram of liquid X were to give up 2 calories to liquid Y, find the change in temperature. All right, so the statement really gives it away that the change in temperature of liquid X, so I'll say X, put a little, has a change of temperature of -1. That's what is meant by having a specific heat of 2 calories per gram per each degree. And so it is saying each gram gives up 2 calories. That means each gram is going to go down 1 degree. All right, so liquid X is going to decrease by 1 degree. Now, let's talk about then liquid Y. Now, liquid Y would have a change in temperature. Okay, so let's see. If this loses 2 and it goes to here, and 2 and goes to here, and 2 and goes to here, and 2 and goes to here, I guess I would say that the 2, 4, 6, 8, 10, 12, there's 12 calories total that are going to be coming out of liquid X because you're losing 2 for every gram. All right, so that's a total of 12. And it's going to go over into here. And so that's going to be 4 calories going into each gram. Now, they made it very clear that the specific heat here is 1 calorie per gram. So that means it would raise by 1 degree for each calorie. So if I take 1 gram, okay, so I'll just look at this 1 gram. Doesn't matter which of the 1 grams, but there's 3 of them, but I'll just take this top one. And it's getting 4 calories dumped into it. And the specific heat says that it will go up 1 degree when there is 1 calorie. So this must go up 4 degrees. So this must go up to 24. So I'd say this is an increase of 4 degrees Celsius. So that might be the easiest way to do it, although I must say that's more of a conceptual approach than it is a mathematical approach, and this is in the exercise part. So they probably want us to do more of a calculation. So all right, so maybe I'll do this, that the the magnitude of the heat lost by X must equal the magnitude of the heat to be gained by Y. All right, so this is an MC delta T. And, of course, solving this then for the heat lost, you can do this in a couple of ways. Maybe I'll just look at the whole liquid X. Because, again, going back to the phrase, how did the author say it? He says it here. The specific heat of liquid X is 2 calories per gram for each degree in the specific... Okay, if each gram of liquid X gives off 2 calories. All right. So knowing that there's 6 of them, I would say that this is going to lose a total of 12 calories. And so now if I put in some numbers here, this mass here is 6 grams for liquid X. The specific heat is 2 calories per gram for each degree. Then there's the change in temperature, and then there is the 12 that is being lost here. And so now you can see how the units would cancel off, and you're going to be left with units of just degrees Celsius. And then this 12 and that 12 would cancel off, so you just got 1. And so the change in temperature is 1. Now, it's a decrease of 1 because it's a loss, so maybe a little more accurate, I should say a loss of 12, so that would be a negative decrease there. So that's how you would do the math. And you could do the same thing for Y. You'd go MC delta T equals, and in this case, you would know that it would gain the 12 calories. So I'll put a plus 12. And you know that the mass of the Y is 3 grams. And the specific heat is the 1 calorie per gram per each degree. And then the delta T. And then you got the plus 12. And so the grams cancel off. The calories cancel off. And you'd be left with degree Celsius. And then, of course, when you do the math, the 12 divided by the 3 is the 4. And so maybe that's a better way. So either conceptually or mathematically, I think it would work, but there's the answer. Hope that helps.